Today we will talk about mathematics and education. We will start with some mathematical contents in the ancient times, and then we will focus on the mathematics education in the contemporary era. We will focus on 4 ancient civilizations, including Babylon, Egypt, Greece, as well as China. So we will start with Babylon. Babylonian mathematics flourished in about 1800 to 1600 BCE. So mainly the clerks and the priests would work on mathematics. Why do they need mathematics? It's because they want to keep records associated with the calendar, land, taxation, and commerce. It seems that there are not much difference with what we are doing today. They kept their mathematics on cuneiform mathematics tablets. If you take a closer look to their mathematics, you will realize that they are doing base 60. So in this video, with the link in your PowerPoint, you can see why they would choose 60 as the base. So right now, please pause this video and spend some time to watch the YouTube video, and then we will come back. Another interesting thing that I want to show you is this article in Science in 2016. So it seems like Babylonian mathematics were older than 3,000 years ago. But right now we can still find articles talking about it. And indeed, in this article, it mentioned that Babylonian used advanced mathematics to predict the positions of stars. We have covered the ancient Egyptians' mathematics in our first tutorial. So they record their mathematics in the Rhine Papyrus in about 1650 BCE. So did you remember what kinds of mathematics they were working on? We will skip Egyptian mathematics at the moment because we have already covered. And let's move to the mathematics in ancient Greece. When we talk about mathematics in ancient Greece, usually we will cover all these people: Pythagoras, Plato, and Aristotle. So Pythagoras learned mathematics from Egypt when he was young. He returned to Greece and set up his school in 518 BCE. He's so eager to teach, and he initially paid students 6 cents for every theorem they learned. So Plato set up his academy in 387 BCE. It lasted over 900 years. It was closed down by the Roman Emperor as a pagan establishment. So he focused on 4 subjects of mathematics. They are arithmetic, geometry, astronomy, and music. I would like you to pay attention to this logo and this printing. So here in the American Mathematical Society, you see that there's some Greek printing on it. And this one as well. And here you can also see this one. So this is the writing, and what does that mean? If you want to know the answer, I would suggest you to watch this YouTube video for about 25 seconds. So please come back after you have finished your YouTube video. Now, we will move our topic to ancient China. One of the most famous mathematical classics in ancient China is the 9 chapters on the mathematical art. It was composed by several generations of scholars, so we do not know who the authors were. Liu Hui, for the 3rd century, was one of the commentators of the 9 chapters. The contents of the 9 chapters are as follows. The first chapter is on land surveying. It teaches us how to find the areas of fields of various shapes, such as rectangles, triangles, trapezoids, as well as circles. In Liu Hui's commentary, it also includes a method in approximating the value of pi, which is 3.14159. The second chapter is on millet and rice. It talks about the exchange of commodities at different rates. It also includes the rules of 3 for solving proportions. The third chapter is distributions by proportion. It derives the arithmetic and geometric sums. The fourth chapter is on short width. It teaches us how to find square roots and cubic roots of any numbers. Chapter 5 is on civil engineering. It finds the volumes of solids of various shapes. Chapter 6 is fair distributions of goods. It includes advanced work problems on proportions like work, distance, and race. Chapter 7 is excess and deficit. It includes linear problems in two unknowns. Chapter 8 solves simultaneous linear equations with the arithmetic of negative number. The method is similar to the modern form of Gaussian elimination. Chapter 9 is on right-angled triangles. Basically, it talks about Pythagoras' theorem. We can see that all of these topics are related to the application of mathematics. Indeed, many mathematical classics in the ancient times focused on the application of mathematics. We have seen these questions before when we talk about the Egyptian mathematics. So in problem 14 of the Moscow Papyrus, it wants to find the volume of a truncated pyramid, or what we call a frustrum. We can find a similar questions in chapter 5 of the 9 chapters of mathematical art. So, question number 10. To find the volume of a pavilion. Right now we have a pavilion. The base is 5, which means A is 5. And the top side is 4, which means B is 4. And the height is 5, which means H is 5. So it asks about the volume, and it gives the answer here. If you know Chinese, it actually changes the unit in the answer. So the method says you multiply this by itself, and you also multiply this by itself, and then you multiply this too. That is why we have a squared, ab, and b squared. These means add them up together. So we have a squared plus ab plus b squared. And multiply by the height, so we multiply by h, and we have a third of it. The whole thing is multiplied by 1/3, and this is the volume. It does not explain how the method is found. It only provides us a formula. Question 15 of chapter 5 is about the volume of a Steinmetz solid. So what is a Steinmetz solid? It is a solid generated by the intersection of two cylinders of equal radius at right angles. It is amazing that well before we have calculus, we are able to find the volume of this solid. It could be an interesting group project topic for you guys. After talking about the mathematical classics in different civilizations, we will talk about the mathematics education in the contemporary era. We will start with some international studies, and we want to see how the East and the West performed. And then we will focus on the Asian views. We will talk about CHC with an Singaporean examinations as an example. We will also talk about the Western views and the inferences. So nowadays, when we talk about the mathematics syllabus, basically they are universal. That means mathematics topics studied in schools are more or less the same across the countries. They are also very broad. That means they contain a broad range of topics. So we are interested in which country did the best in mathematics education. Let's take a look at the trend in 4th grade. So TIMSS here stands for Trends in International Mathematics and Science Studies. So it is a series of international assessments of the mathematics and science knowledge of students around the world. We can see that in 1995, Hong Kong ranked the 4th, and in 2003, Hong Kong ranked the 2nd, and in 2007, Hong Kong ranked the 1st, and in 2011, Hong Kong ranked the 3rd. We can see that Singapore, South Korea, Japan, Hong Kong, and Taiwan are always on the top. These places are in East Asia. We can also take a look at the 8th grade and see whether we got the same trend. So here we also have Singapore, South Korea, Japan, Hong Kong, and Taiwan in different years. from 1995 until 2011. Let's take a look at another international assessment. So PISA, which stands for Program for International Assessment, assess the results of students in mathematics, reading, and science. This time, Shanghai in mainland China first joined this international assessment, and then their students ranked the first in mathematics, reading, and science. And we can see that Shanghai, Singapore, Hong Kong, Taiwan, South Korea, Macau, Japan, they all outperformed their Western counterparts. So there are some memes on the internet, like once you go Asian, you can solve the equation. There are also other memes talk about the different standards to failures. Americans consider 50% to be exam failed. Russians consider 70% to be exam failed. Then Asians consider 98% to be exam failed, year failed, life failed. Of course, this may not be true, but it reflects that students or parents in different cultures have different expectations in examination performance. So how did scholars explain the phenomenon? For many years, the Asian students outperformed their Western counterparts. This is the Dean of Graduate School, Professor Frederick Learned. So he is a mathematics educator. He was awarded the Hans Freudenfeld Medal in 2013. He explains the performance differences between the East and the West by what we call the Confucian heritage culture. Students in the Eastern Asia are often influenced by this Confucian heritage culture. In the eyes of Western cultures, CHC students are perceived as using low-level, rote-based strategies in a classroom environment, which should not be conducive to high achievement. On the other hand, CHC students report a preference for high-leveled, meaning-based learning strategies, and they achieve significantly better in international assessments, as we can see in the previous examples. This is a report on what students think about how well they performed in mathematics. Did you remember that in Singapore, Japan, Hong Kong, they all outperformed their Western counterparts? Let's take a look at Hong Kong. In grade 4, only 70% of the students thought that they did well. In Japan, it's 70-something. In Singapore, it's close to 80. But remember that we are talking about grade 4 students, so they're roughly 10-year-old. And the fact is that they all outperformed their Western counterparts. We can also take a look at the report of grade 8. We see that Korea and Hong Kong, only 30-something% of the students thought that they did well in mathematics. Japan got a bit more, 40-something%. Singapore got 50-something%. For the countries, the students do not perform as good as the Asian countries. We see here, say United States, 80-something% of students in grade 8 thought that they're doing well in mathematics. The feeling that how students performed may also be affected by the parents. So there are always some memes on the internet talking about the Asian parents. For example, 790 on Math 2 SAT subject test. Why you no get 800? Another one, IB standard level math. Why not take IB high level? You got an F on your math test. I can also give you another example. So Jeremy Lin is the basketball player. He studied in Harvard and his GPA is roughly 3 point something. And then the host in the show asked him, is it an Asian failed to get a GPA 3? So in general, the media also portrayed that Asian parents got high expectations on students. And people thought that the Asian grading scale is A for average, B for bad, C for catastrophic, D for disowned, F for forgotten forever. So I'm not saying that this is true, but it reflects in general how people think about Asian cultures and the expectations of Asian parents. Another paradox on the CXC culture is about the teachers. So teachers in the CXC classrooms produce a positive learning outcome using directive teaching. So I have a question for you. Why do teachers prefer directive teaching? In the eyes of the Western educators, they regard directive teaching as teaching under substandard conditions and most unpromising. Do you agree with that? The third paradox is about examinations. So CHC classroom is labeled as dominated by an examination-oriented culture. It is commonly believed that an examination-oriented culture hinders the learning process. It is also believed that the Asians studied mathematics only by rote memorization and industrious drilling. Is it true or not? Can we study mathematics by rote memorization and industrious drilling? Do you think some form of memorization is also important? Do you agree that we need industrious drilling sometimes? So what is a good examination? In my opinion, I think a good examination is composed of the following: knowledge, comprehension, application, analysis, and synthesis. So it is not easy to set a good examination. One important message that I want to deliver is examination-oriented education and quality education need not to be a dichotomy. Here I will give you an example on a Singaporean examination. This is one of the questions in Singapore Primary School Leaving Examination in 2005. Question 13. The figure below shows a rectangle 15 cm by 6 cm. The area of triangle A is 4 cm squared and the area of triangle B is 16 cm squared. What is the area of rectangle C? So right now, please pause the video and try to figure out the answer. I guess some of you would say 20 cm squared. Some of you would say 25 cm squared. But unfortunately, none of these are the correct answer. Why? This is because there is a mistake in the question. 3 primary school students, after the examination, figure out that there is no correct answer for this question. What did these 3 primary school students do? They report to the examination authority about the problem of these questions. So what I'm going to say is, if these students were trained simply by drilling or by rote memorization, they would not be able to tell what the problem is in the questions. So what exactly is the problem? This is what we call the Curry's paradox. It seems like all the pieces matches together. You see the red one, you see the purple one, you see the orange one, you see a green one, but the area are not the same. In this paper of NUS, it tries to explain why. I can also show you another video that I found on Instagram. So just to make a disclaimer that I do not own the video. Speaking of Singapore, I would like to share with you a math problem in 2015. The problem goes wild that it appeared in New York Times. It is a math problem to find Cheryl's birth date using logical deduction. I'll leave the problem to you if you are interested. Right now we will see the response from the Western world on students' performance on Teams and PSERT. This is Wall Street Journal in 2009. So why we are failing math and science? This is 2011 in CNN. US students lag behind in math, science, and reading. This is Global Post in 2012. Test results showed American school children lag behind Asian, European peers in math, science. This is New York Times in 2012. US students still lack globally in math and science. Tests show. This is Entrepreneur in 2013. Report. US adults lag behind international peers in literacy, math, and tech skills. This is Washington Post in 2013. US students lag around average on international science, math, and reading tests. So we see that US is below the average or roughly at the average. Right now we will take a look at responses from UK. In 2013, The Times, anxious UK pupils lag behind in maths. Responses from Germany. In Germany, the first PISA report released in December 2001 caused a sensation. The country that prides itself on its education system, on its contributions to the Western science and philosophy that had produced Einstein, Goethe, and Marx. So this is German Times, January 2008. German students did poorly in math, science, and reading, with limited literacy effectively lowering performance in all subjects. The PISA shock undermined German self-confidence. Germans had always tacitly assumed that they led the world in education, and yet now an international organization has shown that in the 21st century, their education system was well below average. 2013 ARD PISA studied Deutschland's Schüler bleiben Mittelmaß. So German students stay in the middle. In 2013 Press Europe, Europe lags behind. We have already read the response in the Western media. What about their political leaders? Why do the politicians and media care about their students' performance? The mathematics and science performance of the students right now would affect the technology development in the future. So in this figure, we can see that in year 2000, there are roughly 40% of Asians working in the Bay Area. In 2010, the percentage rose to 50%. And technology development is an important sector in economy. That is why politicians care about students' performance. And a lot of countries promote STEM education as well. In order to promote STEM education, the Singaporean Prime Minister shares code for Sudoku puzzle solver. He coded himself. Obama also learned how to code in 2014. But in UK, Osborne had voice tests on his times tables. So here I share the links with you if you have time, and if you are interested, you can take a look at this. While politicians as well as the media expect students to learn more mathematics in school, when do we actually use those advanced mathematics in our everyday life? I would say we are more or less the users of the end product of mathematics. For example, when we log in our bank account, your university portal, or any email systems, basically all of these systems are encrypted. And the encryption is done by number theory in mathematics. When you take any form of transportation, aeroplane, cars, motorcycles, even your bike, the design and manufacturing of all these transportations make use of mathematics and even some of the differential equations. Have you ever seen people playing mobile games on the train? So this is a question posed on Quora. How is mathematics used in video game design and programming? So this is Angry Bird, and indeed, in most of the game forms, they want to make it like reality. So that is why everything in the game needs to match with your real-world experience. Say, when you shoot something, you need to make sure that it goes with the projectile motion. So basically, we know that on the top, the velocity would be 0. And at any point, the vectors can be decomposed into the x and the y component. And the gravity is also the same as what we have on Earth. Let's take a look at the other examples. So this page talks about the use of mathematics in computer games. So basically, if you are the first person shooters, they will almost make it real so that as if like you are looking at the real world. So what kind of mathematics do they use? Oh, geometry, because you need to make sure that everything is similar to what you perceived. And of course, you also need what we call transformations. That's very important. Here's what I mean by transformation. So when you move things and you rotate things, then what would they be? Where would they be? So it's like when you change the position of where you stand, then how the object would move. If you work on like three-dimensional world, you can't avoid having trigonometry. So the game designers use a lot of mathematics. My point is, most of us are the end product users of mathematics, rather than we are using mathematics to create something. While those people who use mathematics to design games, to design transportations, to use it in stock markets, to create a security systems, all of these people actually help the economy of a society. And that is why the politicians would like the students to be equipped with this skill. Still, not many people would want to be a mathematician. So one of the reasons may be the image of mathematicians. This is a picture drawn by a 7th grade pupil. The kid thought that mathematicians got sword-tied eyes and poor body posture and so on. So the image of mathematicians are not that good even to the eye of a kid. I'm going to tell you that not all mathematicians look like this. So this is a professor in UC Berkeley. He is called Edward Frankel. So apart from doing mathematics, he also makes movie. This is the movie trailer. And this is him talking about the application of mathematics. In the video, he's trying to say that mathematics is a culture, and we need to learn mathematics so as to avoid the misuse of mathematics. Our ignorance can be misused by the powers, and that is why everyone needs to learn mathematics. So here are some quotes on education that I like very much and I would like to share with you. So Skinner said that education is what survives when what has been learned has been forgotten. Albert Einstein said education is what remains after one has forgotten everything he learned in school. Education is what left after all that has been learned is forgotten. So it seems that Greek scholars, scientists, educators, they share the idea that the spirit of education does not lie in what actually has been learned. So my point is, it's not how much you remembered you learned in school. It's the logical mind and critical thinking that we trained in school. Thank you very much.